Okay, this chapter is going to finally get to where I want to be. All right, we've been leading up to it for 3 chapters, really. We started with the periodic table and the octet rule, and then last chapter, and even we go back to electrons, even 4 chapters. With electrons, we started talking about how some guys lose, some guys gain, and outer shell electrons and valence electrons and all this stuff, just so we can write formulas, and compounds, because we need these to be able to do reactions. You know, this chapter is going to have about, I think, 3 labs in it. The more you learn, the more you can do in lab. We're finally going to be able to do stuff. Writing formulas is like the first real step, and we've been leading up to it for some time. As you'll see, I'm going to shorten your knowledge of electrons, periodic table, kind of put it all together, octet rule, put it all together to be able to write the correct formulas and to explain why compounds have the formula they have. I've been leading to this for a while. For example, water is H2O. Why is water H2O? Well, you already kind of know. Because H wants to do what with his electrons, oxygen wants to do what with his, how many of it it'll take to make everybody happy. We're just going to write it now. We're not going to have to think about it. We're just going to write it. I'm going to show you how we're going to do that. All right. And today, because we have a double, I'm actually going to do this a little bit differently. I'm hoping to record this and put it up all together, because basically today I'm going to go through 3 types of compounds I can name. All right, we'll start with the easiest ones, I guess, the binary compounds. These are probably the easiest things to name and write. How many elements do you think are in a binary compound? Absolutely. And could you think of a binary compound that I always talk about?
H2O.
Okay, that's correct.
NaCl.
Those are 2 good ones. How about another one? In the atmosphere. CO2. So those are 3 biggies. Okay, we're going to use all 3 of them. Okay? And the funny thing is, you already know how to name those. They are going to illustrate for you. Those common examples are going to illustrate for you. At least one of them, 2 of them are, 2 to 3 are going to illustrate exactly how you name them. For example, if I start with a binary compound that is a metal, well, I already said this, it contains 2 different elements. If I start with a binary compound that is a metal combined with a nonmetal, which one of those that you just mentioned, sodium chloride, carbon dioxide, or water, which one of those 3 is actually a metal and a nonmetal together? NaCl, CO2, or H2O? Look at the periodic table. It's the only 3 compounds, really, there's only been 3, besides sugar. Those are the only 3 compounds that I've asked you to know anything about. Which of those 3 is a metal combined with a nonmetal? Mark. NaCl, right. And you know exactly how to name NaCl. What do you do when you name NaCl? It's going to be my first example in a second. What is NaCl when you call his actual formula? I don't mean salt. I mean his actual formula. How do you read that?
You start.
No. Just give me the answer. What is NaCl?
Sodium chloride.
Sodium chloride. You would all call that sodium chloride, correct? That's all you do. You name the first element, you name the second element, and you add what for a new suffix? IDE. Instead of you didn't call it. Notice you just naturally didn't call it sodium chlorine. You called it sodium chloride, right? Okay, so that makes sense. That's how you name all of them. What if it were Na and F? What do you think you would have called it? Was NaF? Sodium fluoride. NaBr. Sodium bromide. Yeah, that's all you do. What if it's, instead of being sodium, it was potassium and Cl? What would it be?
Potassium chloride.
Yeah. Now, so don't go, when I start giving you these examples, people are going to start wanting to put all kinds of other funky endings to them. As far as you know, as far as we're concerned, we're just talking about metals and nonmetals and binary compounds. It's just name the first guy, name the second guy, and add an IDE. That's it. Okay? In the positive ion, name the negative ion, add an IDE suffix, as in. Oops, sorry. I thought I was going to flip there. as you would do in NaCl. NaCl is, and we all would know this, sodium chloride. Okay? So I don't have a whole lot to teach you here. This is not going to be difficult. If I stopped after these, no one would get them wrong. The problem's going to be, I'm going to teach you 4 different kinds by the end of the day tomorrow, 3 of them today. And you're going to mix them up. You're going to mix them up. All right. Well, that's going to be the biggest problem you have to watch out for. But let's do some examples of these first, to make sure we're good at them. Okay. What would you call that guy? And again, don't go places I haven't told you about yet. What do you think Li3N is going to be based on what I just said were the rules of this? What do you think this guy is? Emily.
Lithium nitro.
Make it a little easier, a little shorter.
Nitride.
Nitride, yeah. Lithium nitride. Okay, I'm glad to hear she didn't try doing things that I said we don't need to do yet. We will need to do them eventually, but not yet. For example, why isn't it trilithium? Well, do we have to put the 3? Does that 3 mean something? No. I didn't say it did yet. Not yet. There's going to be places where it is important, but it's not for a metal and a nonmetal. Lithium nitride is correct. And again, for example, as she was trying to say in the beginning, use a little common sense here. It's not lithium nitrogenide, just because the same reason it's not sodium chlorinide. You change the suffix, you don't add it on to a suffix that's already there, right? No one would have called salt sodium chlorinide. You called it sodium chloride. This is sodium nitride, sodium oxide, sodium sulfide. You see, just drop the one that's there and add IDE, okay? Pretty much common sense stuff. All right. When does this get more difficult? When I do it backwards, because I got to remember something here. I got to use something here. I can't just write what I know you would want to do. Aluminum fluoride is going to be what? Al and F. We all know it's going to be an Al and it's going to be an F, but that's not the whole story. As we know from last chapter and the chapter before that and the chapter before that, the octet rule, electrons, periodic table, predicting this stuff all comes into play here. We're going to put it all together without writing. If those guys back there taking a test, you know what they're doing right now? They're writing out Al. They're writing out F. Electron dot for each, figuring out how many you want to lose, how many you want to gain. We already know that's in the back of our mind, but we are not going to do that every time. It's too long. We're just going to write the charges right in there. What would the charge of Al be if he were going to lose electrons? What would he be? Take a look. There he is. +3, because he's in group 3, he wants to lose 3 electrons, right? What would fluoride's charge be? -1. If I just do that, it's enough information to finish this problem. Because basically, look at it as a math problem now. I got to make these 2 guys equal 0. I got to balance them out. How many of each will I need? How many fluorines am I going to need to make that aluminum happy? 3. And that's where that subscript of 3 comes from. Okay, and I've been hinting at that for some time now, so I don't think that comes as a surprise to anybody, right? But the difference is, we're putting all we learned from the periodic table, electron chapter, and last chapter together. We're putting it all together, and we're just going to do this instead of. Now, that all stuff that stays there. It doesn't mean we don't realize that +3 really means losing 3 electrons to get an octet, gaining 1 electron to get an octet. That's what it means, but we don't have to do it anymore. Okay, try it for this guy. Calcium oxide. Try him on your own. Pretty easy. Look up calcium. Look up oxygen. You know what the 2 elements are going to look like. Look their charges up. Okay, calcium, everybody agree has a +2? And everybody agree O has a -2, right? Do I need any subscripts to make everybody happy here? No, that's it, you're done. But by the way, if you were to look back in your notes or in the worksheets we've done, every one of these that I'm doing here, somewhere throughout the last chapter, we did as electron dot notations and Lewis structures, somewhere. Okay? So it's not like this is new to us. How about this guy? Can you do that one on your own? And to answer your question from before while you're doing that, Emily, no, this chapter is not like the last chapter. This chapter is almost all problems, like these kind of problems and other problems. Last chapter had notes, quite a bit to study, short answer questions. This chapter, almost none of that, almost zero. Multiple choice, matching. I don't think, matter of fact, I'm trying to picture the test. I don't think there's any. Maybe 5%, maybe 10%. 90-some% will be problems like these or others we're going to learn. All right, so nitrate, I hope you all did this. Good? Everybody good with that? Because I got a +1 here, I got a -3 there, I got to have 3 NAs to make that 1 nitrogen happy. All right. Last one. This one does have a twist to it. That's why I saved it for last. Oh, I'm sorry, it isn't the last. There's actually 2 more left. There's one here and then one more, which has another twist. There's 2 twists. Because I think at this point, everybody knows how to do it. All right, so these 2 are going to be some something that you wouldn't expect, perhaps, some little problem you may run into. Both of these are going to have some little difference here. So look at magnesium phosphide, look them up, and you'll see a problem. Do you all have that? And +2 and a -3? There's the problem. There's no one subscript I can put after these guys unless I use a fraction. It's going to be able to be multiplied and balance these guys out. So what do I have to do? Mathematically, if this was a math problem, what would you do? Find the what? Least common multiple, or least common denominator. Of 2 and 3 is 6, right? So what will I need as a subscript of Mg?
3.
A 3. And here? A 2. Remember, these numbers down here, I call them subscripts. They are subscripts. They mean how many atoms you have of that type. So you're actually, if you have 2 P's, each one has a -3 charge, each one gaining 3 electrons, you actually can gain 6 electrons. If you have 3 Mg's, each one losing 2, you can actually lose 6 electrons. 3 times 2 is 6. Okay? The last little problem you may have is with a guy like this. Look where iron is in the periodic table. Find him up there. See him in the smack dab in the middle? You would not be able to tell iron's charge. Everybody I've asked you so far has been a guy that was easy. He's in the group 7, group 8, wants to gain 2, gain 1. Group 1, group 2, wants to lose 1, wants to lose 2. Iron is in the middle. I told you we're not going to worry about them last chapter, but now we do. Iron, I have to tell you what his charge is with a Roman numeral. Okay, that tells me his charge. Okay, what do you think iron's charge is in this case? Yeah, Fe with a +3. And then the bromide, of course, that's not a problem. What's he? Not 7. He's in group 7, but he is -1 because he wants to gain 1. So that'd be FeBr3. Okay. I should mention this because there are professors in college, and I have actually seen this. It's driving. I don't understand why. Well, I do understand why. I know you may hate some high school teachers that you have had over the course of the years. It may be me included. But the fact is, nobody in high school will pale in comparison to how bad some of your college professors will be. All right. For example, they're just looking at their job as weeding you out, especially in the sciences. So they'll make life as hard for you as possible. And there's no mommies or daddies that can call up and actually, change your grade. All right. So for example, this guy right here, he's here. I have no problem with you leaving them like that. But the correct answer, this is an ionic formula, would be to rewrite it again without the charges. So if you don't rewrite it again without the charges, and there's another case we're going to see in a minute where you need parentheses. If you leave parentheses where they don't need them, they'll take off full credit, which is crazy. All right, but that is the actual empirical formula. This is the ionic formula. But as far as I'm concerned, leave them like this. I don't need to write it twice and just leaving the charges out. Okay. All right. But just saying that in case you run into something like that, you always do what they say. Okay, nonmetal, nonmetal. If I don't have a metal combining with a nonmetal, if I have 2 nonmetals combining, and that happens, what was the other example of that? Of a gas in the atmosphere?
Carbon.
Carbon dioxide is a good example. CO2, right? Carbon and oxygen are both on the right side of that periodic table, aren't they? They're both nonmetals. So if I get a nonmetal and a nonmetal together, how do I name him differently? Let me show you. It's going to look exactly the same. Read this before you write it down. Name the first atom, name the second atom, then add IDE. Oh, that's exactly what we just did. But there's going to be one more thing we'll have to do. And CO2 illustrates this. So write that down, and let me show you how CO2 illustrates this. What are you doing when you name CO2 that you did not do for salt, for sodium chloride? When you call that, what do you call CO2? Yeah, just naturally you call him carbon dioxide. You didn't call it carbon oxide. You called him carbon dioxide. So you've got to use a prefix. And those prefixes are on page 151 in a table. Don't open up to it now because you know most of them. You've got to use a prefix after, or I'm sorry, not after, before the word to tell you how many of those atoms you have. And a great illustration of that is carbon dioxide. That's what you would call CO2. How much of the air is carbon dioxide, you think, percentage-wise? 27. 0.03% about. Yeah. Very, very small amount. What's most of the air you're breathing right now? Nitrogen. What about 70%? What's the rest? What's the next biggest thing? Oxygen. Okay. Carbon dioxide is a very small amount. Very small amount. Okay. That's how you would name carbon dioxide, CO2. Okay. How about that guy? Now you can see we're going to get some pretty, hefty numbers to be able to name. What do I do? Well, the prefixes are on the table right there, but you actually know most of them. What do you think the prefix for 1 is? Yeah, what do you call carbon with just one O? Carbon monoxide, right. What do you think 3's prefix is? Tri. What do you think 5's is? You should know 5. Think of 5. 5-sided figure. Penta, yeah. Penta. What do you think 8 is? Oct. What do you think 10 is? Di? Dec, not di. Di would be what? No, di would be 2. Okay, so you do know most of these, but there are a handful you do not and are not familiar with. Like this guy, you're familiar with him. What would you probably call this guy? 2 N's, what's that going to be? Di-nitrogen, di-nitrogen, di. It's like a horror movie. Di-nitrogen.
You don't have to put the I on the first one.
I do not put the I. It only goes at the end. Di-nitrogen what? What do you think we call this guy? Pentoxide. Okay, let's go over a couple of little problems with that, one of which Bo brought up. A couple of other ones I want to mention too. You do not put "-ide" except at the very end. Okay, that's the last word gets "-ide." Okay. Secondly, pent versus penta. If you look at the prefixes in the table, it's going to say penta, hexa, hepta, octa. You use the A if the next letter is going to be a consonant. You don't use the A if it's a vowel. I don't really care. I'm not going to take off if you said pentaoxide, but it should be pentoxide. But if it were a sulfur here, I would have to write what? Pentasulfide. Pentasulfide, you see? Not pentsulfide. You don't put 2 consonants together. Not a big deal, but whatever. And there was one other thing I was going to mention about this guy. It'll come to me. But anyway, so dinitrogen pentoxide would be the correct formula for N2. Oh, yeah, that was the other thing. Notice in this case, I had to actually use a prefix in front of both of them. Somebody's saying, why didn't you call this monocarbon dioxide? You could have. But when the first element has only 1, you don't need to put the mono. Okay? When the first element only. The second element, it doesn't really matter. The second one always gets it. That's why, for example, what's this? What's the name of that? See, carbon monoxide. Which carbon monoxide poisoning? You've heard of that, right? Okay. All right. Now, next one. Carbon disulfide. How would I write the formula for that guy? How would I write the formula? Now, I've noticed, okay, you want to write the formula for that? What am I going to do to write the formula for that? I know some people I notice are looking at the periodic table, thinking to myself, okay, I got to look up carbon and its charge, and I got to look up sulfur and its charge. But that's not true. What is carbon disulfide? CS2. That's all I have to do. Why do I not need to write the charge down? Because it tells it to you. When you have two nonmetals, it tells you how many of each. And here's another reason why, if you think about it. Can I ever balance out the charges from two nonmetals together? What are they both going to be? Both of the guys on the right-hand side, if I were to look at the charges up, are going to be what? They're going to be one electrons, which means they're going to be what charge? Negative. So you're never going to be able to balance them out like you can with sodium with a +1 and chlorine with a -1 balances out. Or if it were something with a -2, you put a 2 there. That you can balance out because one guy's losing, one guy's gaining. Here they're sharing. So looking those charges up is kind of useless. You might wonder yourself, why am I bothering to put prefixes for these guys and not for the other ones? All right, well, turns out these guys often have multiple ways to write the same two guys getting together. All right, carbon dioxide and carbon monoxide, again, a classic example. So you have to illustrate. There's only one sodium chloride. There's no such thing as Na2Cl. There's only NaCl. That's it. When salt gets together, sodium gets together with chlorine to make salt, it's NaCl. But when carbon gets together to make, with oxygen to make, he can make carbon dioxide or carbon monoxide. And same thing's true with NO and P and O and S and all these other guys. Something in my throat. Okay, try one more. P4O10, if you could do him, I don't think you're getting anything wrong. Four is one of those guys, let me help you out with. I went through all the ones you did know. I saved the ones you probably wouldn't. Let's start with the easiest of those. You guys know what the prefix for 6 is? Hex, good. How about for 7? Hep, good. The hardest one then for most of you is going to be 4. What do you all think of when you think of 4? Quad. It's not. It's tetra. And the way to remember this absolutely blew everyone's mind. Tetris. Do you know why? Remember that game Tetris where you had those little falling blocks that look like this? Remember this? Some were like this, and some were like this, right? And some were just a cube, right? Remember that? When they fall, you have to turn them around and fit them together. Do you know why it was called Tetris? Did you ever notice that each of those is made of 4 blocks?
Holy crap.
I know. Caitlin, Hannah was like, they were like blown away in the other class. That like made their day yesterday.
Russian science is blowing my mind.
This is the most important thing you'll learn all year. Tetris stands for what? 4. So if you ever want to, that's the one that's the hardest to remember. All right, remember all the different blocks you had? Yeah, this kind too, right? Remember that one? That was always the hardest one to fix. If you screwed him up, you couldn't sneak anything else in there, you know? Huh?
Yeah.
Right? Okay. Oh, the easiest one was this one. You're always waiting for this guy to come around because then you can send him right down and get 4 on bam, get some good points. Remember that?
Yeah.
Okay. You can tell my games are a little bit less than Call of Duty. Not quite the same scale. Or Halo 18. Whatever. So what do you think P4O10 is going to be?
Tetraphosphorus decoxide.
Tetraphosphorus decoxide is correct.
Yes. Yes.
How about that? Don't you sound impressed by that? Are you impressed by that?
Yeah, just wait till my test rate comes back.
Phosphorus
I
decoxide.
hate smelling phosphorus.
All right.
I always want to put a U after the first one.
I always want to put it.
I know, me too. Me too. All right. Now, I stopped there with the other class because they only had 1 period yesterday, 1 period today. I split it up. But since you guys, what I'm going to do is things a little bit differently with you. I'm going to go through the next type right now. They got that today. And then have you practice for the rest of the period, however much we have left to do this. And then next period, I've got just an exercise I want to do with you that they did today in class. Okay, so we'll see. let's do ternary right into it right now while we're still fresh in our mind, because we'll see right away how you can start confusing these. Thank you.
Oh.
Now, ternary compounds, binary had 2. What do you think ternary is going to have?
3.
Yeah, well, that kind of says it there. So, gave it away. Gave it away. Give it away, give it away, give it away. Okay. All right. Ternary compounds are going to have multiple, actually it doesn't always have to be 3, it can actually be more than that, but they're going to have at least 3 elements in their formula. All right, and so they're going to be named differently. They're going to have what are called polyatomic ions. Okay, now you copy that down while I pass out. This sheet contains a list of the polyatomic ions you have to be able to use.
Do you memorize this?
No, and that's why you should all be kissing me right now.
Oh,
Hey, you're right. I got a cold sore anyway.
Mr. Allen, I don't love that.
Funny, like that's why he's not here.
You should all be very happy though, because I got to tell you, I've gone to conferences in a lot of other schools, a lot of other school districts, a lot of other high school teachers, and certainly when I was in high school, you would have to memorize these. Okay, I don't make you memorize these. Everything on the sheet would have to be memorized at one point or another. If you go to college, you will, of course, have to memorize them. But here's the beauty of this. I'm not going to make you memorize them, but by the end of this year, you're going to know them anyway, just from using them. Okay? There's a lot of things like that. Look at that periodic table. You may find this amazing, but by the end of really a couple of weeks, maybe even a month, you're going to know, without looking, the atomic mass of oxygen is 15.999. You're going to know carbon's 12.011. You're going to know sodium's 22. You're going to know all of these things just from having used them so much. I'm not going to make you memorize periodic table. I always get your parents in here. Oh, when I was in high school, I had to memorize the periodic table. Well, first of all, I don't think anyone ever made you memorize the periodic table. Okay, ever. Even when I was in school, or your parents or your grandparents were in school. You did not memorize the periodic table. It's there for a reason, so you can look at it. You don't have to memorize it. But even so, it is amazing how much you will actually commit to memory. The ones that are most important in these polyatomic ions, you're going to know by the end of the year anyway.
Like I know that oxygen is in group 6 without even looking.
Right. You kind of know, like all the halogens are -1 already anyway, right? You kind of know sodium. You use them a lot as +1, right? And all of that stuff starts to stick. By the end of the year, you end up not even having to look for some of these guys. All right, anyway, let's talk about how we would name these guys. You ready? Here's an example, NaNO3. Now, I know if I just gave this to you without that sheet in front of you, you probably would have called this guy sodium nitrogen trioxide or something like that, right? And that's what some people will do who don't listen today and don't learn this. You can't mix up. You can't mix and match these methods. You can only use the binary system for metals and nonmetals for that, nonmetals and nonmetals that way, and this one is named completely different. Can anybody look at that sheet and tell me what NaNO3 probably is called? What do you think? Take a look. Find something that looks similar on there, and see if you can't. Raise your hand and tell me. What do you think? Jared?
Sodium nitrate.
Absolutely. Sodium nitrate. Sodium nitrate. If you look at that sheet, under -1, all the polyatomic ions that have a -1 charge, you'll find NO3 on there. And his name is nitrate. Notice the difference. The suffix is not "ide." That's a dead giveaway. In both of the ones we did for binary compounds, whether it was metal, nonmetal, or 2 nonmetals, how do they all end? They all ended. The last 3 letters were what? IDE. For the most of the polyatomic ions, most, not all, they're going to end ATE. They're going to end in 8. We'll learn about the guys who don't, starting, well, a little bit today, but mostly tomorrow. All right, let's do another one. See if we can get this guy. And then we'll do some backwards. What do you think this guy is? Don't let the parentheses, don't let the subscripts fool you. What would you call this guy? What do you think, Josh? You, Josh.
Magnesium.
Where should you be looking for the next word you're going to say out of your mouth? Where should you be looking?
On this paper.
That's right. Take a look. Marvin.
Magnesium chloride. Chlorate.
Magnesium chloride.
Why is it not?
I just said, as I was telling you to think of your name, do not let the subscripts worry you. Did we worry about subscripts when we had a metal and a non-metal together? Did we have to use a prefix then? Where is the only place you're going to ever use a prefix of di or tri or tetra or any? Two non-metals. Two non-metals. Only time. All right, let's try working these backwards. Lithium sulfate. If I told you had lithium sulfate, could you use a chart to tell me the formula? Try it. By the way, most of you are going to like this chapter test better because this is one of those tests, unlike the last one, you will not have to study for pretty much at all. If you are here and not absent, and you're paying attention to doing the homework and doing the worksheets that I give you and do the labs, you can't do poorly on this test. Okay? And you won't have to study. You won't have to go home the night before and memorize a bunch of stuff. Because it's all problems. You're going to get to use the sheet I just gave you, periodic table, and those two things are going to give you pretty much everything you need. +1 for, oh, did you forget about the charges? Did you just write LiSO4 and say that was the end of it? Well, it's not. The Li has a +1 charge. What charge does the SO4 have? What charge does he have? Take a look. Look at your sheet. You cannot look up here. I see Nikki looking up here. No, that's sulfide. Look at your sheet. Look at the SO4 on the sheet. Find him. What's his charge? -2. Notice what I did there. I put little parentheses around here. You know why I'm doing that? To show you that that -2 applies to the whole sulfate bunch of atoms, the whole polyatomic ion. So what is the charge going to be? Or, I'm sorry, what's the subscript going to be for lithium? 2. Now let me explain why I did that. And again, I go back to like somebody who's in college, a college professor, what they might do. That I have no problem with you leaving it like that, but the fact is, you really should write it like this and leave out the parentheses. Why did I put the parentheses in there? To remind you that that -2 applies to the whole thing. If I just put the -2 up here and went, what might you be tempted to do at this point? 4 times -2, multiply those together, like you did in the other cases, right? And that's not what you do. That -2 is for that whole thing, okay? All right, last one, and I am done with the notes. We'll take a break, and we'll come back and do something I told you I wanted to do today. Iron 2 phosphate. Try that guy. I could use the end of the period probably before the bell rings to give you your test grades. Iron 2 phosphate? Yes, there is. I beg to differ. Then you need to look and stop singing. She gets singing in anywhere she can.
But I hate the swing.
And she hates swings.
And bottom.
So if you see a swing set, don't let her get on it.
You know what? You're starting to sound. Are you hanging around with Mr. Phillips?
Oh no, my jokes are way worse than Phillips. Way worse. I pride myself on my bad jokes.
You're starting to sound like Phillips.
All right, Fe. Now again, we saw this before. That Roman numeral tells me the charge. What is it? +2. Phosphate, Emily.
PO4.
Correct. I thought you couldn't find it. There's a 4 there. And he's a -3. Thank you. All right, +2 and -3. What do you think?
6.
3 and 2.
Yeah, 3 here and then a 2 there. Got it? And that will be the correct formula for iron 2 phosphate. Got it?
Wait, so we're gonna put